All right, in this video, we're going to talk about section 1.2, dealing with linear equations and rational expressions. Okay. In this video, we're going to solve linear equations in one variable. Then we're going to solve linear equations containing fractions, also solve rational equations with variables in the denominator, and recognize identities, conditional equations, and inconsistent equations. So those are the things we'll look at in this section. First of all, we'll define what a linear equation is. It is a linear equation in one variable, which we'll call x, is an equation that can be written in the form ax plus b equal to 0. And here a and b are real numbers, and a is not equal to 0. That's the definition of a linear equation. Now let's solve a linear equation. How do we solve a linear equation? When we solve a linear equation involving x, here we're going to determine all the values of x that result in a true statement. And such values are solutions, or sometimes called roots of the equation. Okay, so here, how we generate equivalent equations, and this is just a procedure that I'm giving you here in this case. Number one, you'll simplify an expression by removing grouping symbols and combining like terms. Then number two, you're going to add or subtract the same real number or variable expressions on both sides of the equations. And then number three, multiply or divide by the same non-zero quantity on both sides of the equation. And then number four, you're going to interchange the two sides of the equations. So in this first example, we got 4x plus 5 equals to 29. And in this case, we have a two-step equation that we want to solve for x. So we start by looking at what we have here. We're taking the value of x, multiplying it by 4, then we're adding 5 to it to get 29. Now we're going to do the reverse of this using inverse operations here to isolate x. So we're adding 5. The opposite of adding 5 would be to subtract 5. So that means I need to subtract 5 on the left side. And if I'm subtracting 5 on the left side, I also need to subtract 5 on the right side of that equation. Now, adding and subtracting the same number is the same as adding 0. So when I add 5 and subtract 5, I'm going to get 0. And then I'll be left with 4x. So there'll be 4x here equals to 29 minus 5 will be 24. So I have 4x is equal to 24. And then the next step would be to get rid of the 4, or get x by itself. I'm multiplying it by 4, by the way, so that means I need to divide both sides of this equation by 4. As you can see. So 4x divided by 4 would just be x, then that's equal to 24 divided by 4, which is 6. So here x equals 6 is my proposed solution. However, it does say solve and check. So that means to verify that x equals 6 is the solution for this linear equation, I need to do the check. And to do that, I take my original equation of 4x plus 5 equals 29. And then substitute each x with the 6. Well, there's only one x, so I just replace that x with the 6. So I have 4 times 6 plus 5, and I want to know if that's going to be equal to 29. Notice I put a question mark above the equal sign because I want to ask myself, does 4 times 6 plus 5 give me 29? Well, let's find out. 4 times 6, that's 24. Then does 24 plus 5 equal 29? Well, add 5 and 24 together, you will get 29. And it does. So that checks. So I can say for certainty, x equals 6 is the solution to that linear equation. Okay. Now, on the next page is how we solve a linear equation in one variable. The one that I just did was a two-step equation. Let's say you had multiple steps in your equation and you want to solve for x. All right, so here we go. The first step is to simplify the algebraic expression on each side by removing the grouping symbols and combining like terms. Any grouping symbols means parentheses or brackets or braces. Then you combine like terms on each side. Then number 2, you want to collect all the variable terms on one side and all the numbers or constant terms on the other side. And then number 3 is to isolate the variable and solve. And then finally, number 4, you'll check your proposed solution in the original equation that you started off with. Okay, so let's see how we can apply this procedure to these examples here, like this one. Let's say we got 2 times the quantity x minus 1 plus 3, and then that's equal to x minus 3 times the quantity x plus 1. And here I want to solve this equation and check. Well, the first thing I need to do here is simplify each side by removing the parentheses and combining like terms. So in this case, on the left side, I need to remove the parentheses by using what they call the distributive property. So I got to do 2 times x and then 2 times minus 1. Well, 2 times x, that's 2x, minus 2 times 1, which is 2. Bring down the plus 3, then that's equal to x. Now I got a minus 3 in front. That needs to be distributed over the x plus 1. And keep in mind, when you distribute a negative, you're just simply changing the sign of each and every term inside the parentheses to the opposite. So this is like minus 3 times x, and then minus 3 times the plus 1. Minus 3 times x will be minus 3x. Now, minus 3 times a plus 1 would be a minus 3. So I get x minus 3x minus 3 on the right side. Then on each side, I combine like terms here. On the left side, bring down the 2x, and then minus 2 times a plus 3 will be a plus 1. So on the left side, I get 2x plus 1 equals combine x minus 3x. This x is like a 1x. So 1x minus 3x would be minus 2x, and then minus 3. And then next we move all the variable terms on the left side, preferably, and all the constant terms on the other side. I'm going to move the minus 2x over to where the 2x is. Well, it's a minus 2x, so, well, negative 2x, I should say. The opposite of negative 2x will be positive 2x. So I'll just add 2x on both sides. So here, 2x plus another 2x, that will be 4x plus 1 equal to, and here I got negative 3 here, and make sure you bring the negative in front of the 3 with it. I see students, when they solve equations, when they bring terms down, they forget to bring the negative or the minus sign in front. Now I need to get 4x by itself. I'm adding 1, so the opposite of adding 1 will be to subtract 1 on both sides of this equation. So here we got 4x is equal to negative 3 minus 1 would be negative 4. So 4x equals negative 4. And then to solve for x, I'm multiplying it by 4. I need to divide both sides by 4. So I'm going to end up with x equaling to negative 1. Now that's my proposed solution for this equation. However, I need to do the check. Because the directions does say solve and check. So I'm going to take my original equation. I'll just rewrite it. And for each and every x in this equation, I'm going to substitute it with -1. So this will be 2 times x is substituted with -1 minus 1 plus 3 equal that x is substituted with -1 minus 3 times parentheses x again, -1 plus 1. Now go ahead and put a question mark on top of that equal sign because I want to know if the left side equals the right side. Simplify the left side, you got this 2 times. -1 minus 1 will be -2. Then plus 3. I want to know what that's going to be equal to. Let's bring down the -1 minus 3 times. -1 plus 1 is 0. Now on the left side, -2 times -2 would be -4 plus 3. I want to know if that's going to be equal to -1 minus 3 times 0 is 0. Well, -4 plus 3 on the left will be -1. -1 minus 0 does equal to -1. So -1 does equal to -1. That checks. So here x equals 1 is the solution to that linear equation. Okay. All right, here's another example. Say we had this, 4 times the quantity 2x plus 1 equals 29 plus 3 times the quantity 2x minus 5. You'll want to solve this equation and check. So on each side, I'm going to remove the parentheses and combine like terms. So on the left side, I have to multiply the 4 times the 2x and 4 times 1. Well, 4 times 2x, that's going to give me 8x. And then plus 4 times 1 will be 4. So I got 8x plus 4. And then that's equal to, bring down the 29 and then plus, distribute the 3 over the 2x and the minus 5. Well, 3x times 2x is 6x. And then 3 times 2x is 6x. 3 times the minus 5 will be a minus 15. So on the right side, I got 29 plus 6x minus 15. The left side is already simplified, so I'll just bring down the 8x plus 4 because I had nothing to combine with, but I do have something to combine on the right side. 29 minus 15. Well, if I do 29 minus 15, that's going to be 14. And then bring down the plus 6x. So I get 8x plus 4 is equal to 14 plus 6x. And then I'll get all the variable terms on one side and the constant terms on the other side. So in my case, since I don't want to deal with a lot of negatives, it'll be best to move the 6x over to where the 8x is. Best to move the variable over that has the smallest coefficient over to the other side. So I'll move the 6x over to where the 8x is by subtracting 6x on both sides. So in this case, 8x minus 6x, that's going to be 2x plus 4, that's equal to 14. And then to solve, well, to get the 2x by itself, I'm adding 4. I need to subtract 4 on both sides. So I will have 2x is equal to 10. And to get x by itself, I'm multiplying it by 2. I need to divide both sides by 2. So that means x is equal to 5. Okay, but again, I need to do the check as well. So let me bring down the 4 times the quantity 2x plus 1 equals 29 plus 3 times 2, the quantity 2x minus 5. And then we're going to substitute each x with our proposed solution of 5. So on the left side, I have 4 times 2 times 5 plus 1. I want to note that's going to be equal to 29 plus 3 times the quantity 2 times x. Again, that's going to be 5 minus 5. And then we just simplify each side. Like on the left side, 2 times 5, well, I bring down the 4, and in parentheses, I have 2 times 5. That's going to be 10 plus 1. I want to note that's equal to 29 plus 3. And inside the parentheses, I do 2 times 5. That's going to be 10 minus 5. Still simplifying what's inside the parentheses here. Bring this 4 down, and 10 plus 1 would be 11. Well, no, that's equal to 29 plus 3 times 10 minus 5 will be 5. Well, if I multiply 4 times 11, that's 44. Well, no, that's equal to 29 plus 3 times 5, which will be 15. The right side, add 29 and 15, you will get 44, which is the same as what we got on the left side. So that checks. So this means x equals 5 is the solution to that linear equation. Okay. All right, now let's look at linear equations that have fractions in them. So to solve a linear equation that has a fraction in it, we begin by multiplying each term in the equations by the least common denominator. And to remind you of what the least common denominator is, it is the smallest number that all denominators will divide into. Okay. That's the smallest multiple for each of those numbers that are in the denominator. So like in this example right here, we want to solve and check, which is in this case 5 plus the quantity, well, 5 plus x minus 2 all over 3 equals x plus 3 all over 8. Now notice we got a 3 and an 8 in the denominator. So that means we need to find what the LCD is for 3 and 8. That means we need to look for the smallest multiple for 3 and 8. In this case, it's going to be 24. Now, if you didn't know that, you could do this. For 3 and 8, list all the multiples of 3 and all the multiples for 8. For the multiples of 3, you have 3, 6, 9, 12, 15, 12, 15, 18, 21, 24. And then for 8, you have 8, 16, 24. I'll stop at 24 because notice 24 is in both of these. So 24 has to be the least common denominator. So the way we solve this equation, we're going to multiply each and every term in this equation by 24. So that means this 5 will be multiplied by 24. And then plus x minus 2 over 3 will also be multiplied by 24. It's equal to, and then this x plus 3 over 8 will be multiplied by 24. all right? So I'm multiplying each and every term by 24 in that equation. Now, let's simplify this. If we multiply 5 times 4, that would give me 120. Plus, in this case, when I divide 3 into 24, that would go 8 times. 3 goes into 24 8 times. So you're going to have 8 times the quantity x minus 2. That's equal to, now for this term right here, if I divide 8 into 24, that would go 3 times. So on this side, I will have 3 times the quantity x plus 3. Now notice I have an equation that has no fractions in it. And I can solve this just like I solved the other equations in the previous examples. Remove the parentheses and combine some like terms here. So I'm going to bring down the 120 plus, distribute the 8 over the x minus 2. This will be 8 times x, which is 8x, minus 8 times 2, which is 16. Then that's equal to, also distribute the 3 over the x plus 3. 3 times x, that would be 3x, plus 3 times 3, that's 9. And now I'm ready to combine some like terms here on this side. 120 minus 120 minus 16, that's going to be 104 plus 8x. That's equal to 3x plus 9. There's nothing to combine with on the right side. Now we're going to move some variables, all the variables over on the left side, preferably, and all the constant terms on the right side. Let's move the 3x over to where the 8x is by subtracting 3x on both sides. So here I got 104. And then 8x minus 3x will be a plus 5x equals 9. Now to get the 5x by itself, I'm adding 104. It's a positive 104. So the opposite of that would be negative. So I need to subtract 104 on both sides of this equation. So that means I'm going to have 5x is equal to 9 minus 104 would be a negative 95. So I got 5x equals negative 95. And then divide both sides by 5 to get x by itself. So x is equal to negative 19. Now that is my proposed solution. However, as painful as it may seem, we're going to have to do the check on this one. So let's do this. I'm going to write the original equation. And then I'm going to substitute each x with negative 19. So here I'm going to have 5 plus x, which is negative 19, minus 2. All that's going to be over 3, equaling to x again, that's negative 19 plus 3, all over 8. Again, let me put the question mark there. Let's see. Bring down this 5. Negative 19 minus 2, that's like negative 19 plus negative 2. That's going to be negative 21 over 3. I want to know if that's equal to negative 19 plus 3 will be negative 16 over 8. And now I'm going to simplify. I know negative 21 plus 3 is a negative 7. So this is 5 plus negative 7. I want to know if that's equal to negative 16 divided by 8 would be negative 2. And if I add 5 and negative 7 together, I will get negative 2. which does equal to -2, so that checks. And that will mean x equal -19 is the solution to that equation. Okay. Here's another example. Let's say we want to solve and check this equation. X minus 3 divided by 4 equals 5/14 minus x plus 5 divided by 7. And here I want to solve and check. In this case right here, I need a least common denominator of 4, 14, and 7. Four, 14, and 7. So if you want to do this off to the side, if I list the multiples of 4, it will be something like this: 4, 8, 12, 16, 20, 24, 28. Now let's stop at 28 because you're going to see why. Because when I list the multiples of 14, I'm going to have 14 and then 28. And of course, for 7, this will be 7, 14, 21, 28. Notice that 28 is the smallest multiple for 4, 14, and 7. That's the first smallest multiple that we can come across. So the least common multiple, or the least common denominator, will be 28. So that means we're going to multiply each and every term in this linear equation by 28. So here I'm going to have, in this case, 28 times x minus 3 over 4. That's equal to 28 times 5/14 minus 28 times x plus 5 over 7. And now we're going to simplify all of this. In this case, for this first term, if I divide 4 into 28, that will go 7 times. So that means I'm going to have 7 times the quantity x minus 3. And that's going to be equal to, for 28 times 5 over 14, this is simply like 28 over 1, by the way, if you're not familiar with that. Divide 14 into 28, that's going to go 2 times. So I'm going to have 2 times 5, and then minus, treat that 28 as 28 over 1, and divide 7 into 28, that will go 4 times. So that means I'm going to have 4 times the quantity x plus 5. Now, let's simplify all this by removing parentheses and combining like terms. So if I do 7 times this x, that will be 7x. And then 7 times minus 3 will be minus 21. That's equal to 2 times 5, which is 10. Now, for the minus 4, make sure that you distribute the negative as well. So when you do minus 4 times x, that would be minus 4x. And then minus 4 times the plus 5, that's going to be minus 20. Now on the right side, I need to combine some like terms here. So here I'm going to do 7x, bring down the 7x minus 21, and that's equal to 10 minus 20. That would be negative 10 minus 4x. And then I need to bring all the the variables on one side and the numerical terms on the other side. I'm going to move the minus 4x where the 7x is. And I'm going to do that by adding 4x on both sides since it's subtraction. So 7x plus 4x is 11x. Bring down that minus 21, and that's equal to negative 10. And now I need to get 11x by itself. I'm subtracting 21, so I need to add 21 to both sides of this equation. So that means 11x will be equal to negative 10 plus 21 will be 11. So I have 11x equal to 11. And to solve for x, I need to divide both sides by 11. And 11 divided by 11 will give me 1. So x equals 1 is my proposed solution. Now, of course, I have to do the check here. I'm going to write the original equation, x minus 3 over 4 equals 5/14 minus x plus 5 divided by 7. And substitute each x with the 1. So on the left side, I have 1 minus 3 over 4. I want to know if that's equal to 5 over 14 minus x, which is 1 plus 5 over 7. Now on the left side, if I do 1 minus 3, that's negative 2. So I have negative 2/4. I want to know if that's equal to this. 5/14, bring that down, minus 1 plus 5, that's 6 over 7. Now, if I reduce negative 2/4, that's going to be negative 1/2. But on the right side, I need a common denominator for 14 and 7. Which is 14. Because I know 14 is divisible by 7. And I've already got the 14 right here for 5/14. But if I want to make 6/7 an equivalent fraction with a denominator of 14, I need to multiply the numerator and the denominator by 2. Because I know 7 goes into 14 2 times. So that's why I'm multiplying the numerator and the denominator by 2. So I got 5/14 minus 6 times 2 is 12 over 7 times 2, which will be 14. Now, I have like denominators. I can subtract the numerators. 5 minus 12, which will be negative 7. And if I reduce negative 7 over 14, that will be negative 1/2. So here, this checks. So that means x equals 1 is the solution for that equation with fractions. Okay. All right, next we'll look at rational equations. And this is where the variable will be in the denominator. Okay. A rational equation is an equation containing one or more rational expressions. In other words, the variable is in the denominator. The solution procedure still involves multiplying both sides of the equation by the least common denominator. However, this is going to be very important. We must avoid any values of the variable that will make the denominator 0. We have to avoid any variables, any values of x that would give us a 0 in the denominator. Like in this example, here we got 7 over 2x minus 5 over 3x equals 22 over 3. Notice we got a variable here and here in the denominator. So we need to first find out what our restricted values are going to be. That will be the first thing we do before we attempt to solve this equation. We need to find our restricted values. In other words, what values of x that would give us a 0 in the denominator? And we do that by setting each denominator that has a variable in it equal to 0. So we set this 2x to be equal to 0, and we set 3x to be equal to 0. We don't set the 3 equal to 0 because that 3 does not have a variable in the denominator. And then we solve for x. So for 2x equal to 0, if I divide by 2, you're going to get x equals 0. And likewise, for 3x equal to 0, divide by 3, you'll also get x equals 0. So the only restricted value for this equation would be x equal to 0. Because at 0, this denominator will have a 0 in it. And for this expression, I would get a 0 in the denominator as well. Now let's solve this equation. Well, let's find our LCD for 2x, 3x, and 3. Well, for the numerical terms, well, for the numbers, for 2 and 3, that LCD will have to be 6. And we have an x in the denominator as well, so we need to include the x as well. So 6x will be our least common denominator. And now we're going to multiply each and every term by that LCD of 6x. So let's start by doing this. The 6x is going to be multiplied by 7 minus 2x, and then minus 6x will be multiplied by 5 over 3x. Is equal to, and then 6x again would be multiplied by 22 over 3. Okay. Because here I'm trying to get rid of all these fractions that I have here. Okay, so now let's look at 6x times 7 minus 2x. The x's are gone. If I divide 2 into 6, that's going to go 3 times. So that means I'm going to have 3 times 7 minus, for 6 times 5 over 3x, 6x times 5 over 3x, these x's are gone. And if I divide 3 into 6, that will go 2 times. So 2 times 5 is what I have here, equals, now for the 6x times 22 over 3, the 3 will go into the 6 2 times. So this one will have 2x times 22. Now let's simplify all of this. 3 times 7 is 21, minus 2 times 5 will be 10. That's equal to 2x times 22, or 22 times 2 will be 44. X. Now, if I subtract 21 minus 10, that will be 11. So that's 11 is equal to 44x. And to solve for x, I'm multiplying it by 44, so I need to divide both sides by 44. So that means x is equal to 11 over 44. I can reduce 11 over 44 to 1/4. Now, a good way to check to see if this satisfies the equation, well, you don't have to do the check. But just think of this. My restricted value is x equals 0. Is this my restricted value. It's not, okay? So I can conclude that x equal 1/4 is the solution to that rational equation. Okay. Here's the next example. Similar to that, 5/2x is equal to 17/18 minus 1/3x. I'm going to solve this equation as well. So first I need the restricted values here. So here I got a 2x and a 3x in the denominator. I'll set those each to be equal to 0. So 3x will be equal to 0 and 2x is equal to 0. Well, since 3x is equal to 0, I already know x has to be equal to 0. And for 2x equal to 0, that means also x is equal to 0. Because you have to think of what number times the given number in front that would give you 0. And obviously it has to be 0. So the only restricted value I have here is x is equal to 0. That's the value that would make this denominator and that denominator 0. Now next I will just find the LCD of 2x, 18, and 3x. Well, let's look at the 2 and the 18 and the 3. The smallest multiple for that would have to be 18, because I know 18 is divisible by 2 and it's divisible by 3. And 18 is divisible by itself. And then I also have the x as well. So 18x would be my least common denominator. So the next step would be to multiply each and every term in this equation by 18x. So in this case, 18x would be multiplied by 5/2x equals, then 18x would be multiplied by 17/18 minus 18x also would be multiplied by 1/3x. Now let's simplify each of these terms in this equation. Okay, on the left side, these x's are gone. And if I divide 2 into 18, that would go 9 times. So I'm going to have 9 times 5 on this side equals, for this term right here, I can only divide out the 18s. That's gone. And then I have 17 times x, or 17x. And then minus, these x's are gone. And then 3 into 18 goes 6 times. So I'll have 6 times 1. Now, if I multiply 9 times 5, that will be 45, equal to 17x minus 6 times 1, which will be 6. So I got 45 equal to 17x minus 6. Now I need to get 17x by itself. I'm subtracting 6. I need to add 6 on both sides. That will mean 45 plus 6 is 51. That will be equal to 17x. Or 17x equals 51. Now to solve for x, I'm multiplying by 17. So I need to divide both sides by 17. That means x is equal to 51 divided by 17 is 3. Now, compare that to our restricted value. Is x equal 3 our restricted value? It's not. So here, x equals 3 is the solution to that rational equation. All right, next example. Now let's say we had something like this. 2 divided by x minus 2 is equal to x divided by x minus 2, and then minus 2 on the outside. Here I want to solve this equation. The only restricted value that I have here is, well, the only term that has an x in the denominator is just x minus 2. So for the restricted value, I'll take that x minus 2, set that equal to 0, and solve for x. So if x minus 2 is equal to 0, that means that x has to be equal to 2. So the restricted value here is x is equal to 2. That's the value of x that we give you. 0 in this denominator and a 0 in that denominator. And now I need my LCD. Well, the only least common denominator I have is that expression x minus 2. So that's the LCD right there. And then I'm going to multiply each and every term in that equation by the least common denominator of x minus 2. So here we go. The x minus 2 will be multiplied by 2 over x minus 2. That's equal to x minus 2 will also be multiplied by x over x minus 2 minus 2 times the 2 has to be multiplied by x minus 2 as well. And now let's simplify. On the left side, the x minus 2's divide out. So all I have there is just 2 equals, in this term, the x minus 2's divide out. I'm left with just x. Now that minus 2 is going to be multiplied by x minus 2. I have to distribute that minus 2 over this. So minus 2 times x will be a minus 2x. And the minus 2 times the minus 2 will be a plus 4. So I got 2 is equal to x minus 2x plus 4. And now I'm ready to simplify this. Bring this 2 down. Let's see, x minus 2x is it's like 1x minus 2x. That's going to be a negative 1x, or just minus x plus 4. And then to get minus x or negative x by itself, I need to subtract 4 on both sides. So that means 2 minus 4 is negative 2 equals negative x. And to get rid of the negative that's in front, I'll divide both sides by negative 1. That would mean x is equal to negative 2 divided by negative 1 would be a positive 2. Now notice here, my solution is the same as the restricted value. When that happens, we cross that out. And by the way, if you were to do the check on this, you're going to find out that you're going to get a 0 in this denominator and a 0 in that denominator as well. And you're not going to be able to get anywhere with it because division by 0 is undefined. So the solution here would be actually no solution, because there is no value of x that will satisfy this equation. And sometimes they use this symbol, a circle with a slash, meaning the empty set. That's what this is. Because there are no values of x that will satisfy that equation. Okay, here's another example. Let's say we got x over x minus 2 is equal to 2 over x minus 2 minus 2/3. Now, if you want to, you can pause this video and then work on this problem and see if you come up with the answer that I came up with, okay, as I work it out. Okay, here's what we're going to do here. Find out what our restricted value is going to be. Now, notice we got x minus 2 in the denominator. We'll use that and set that equal to 0 and solve for x. So for x minus 2 is equal to 0, that means x is equal to 2. So x equals 2 is your restricted value. Okay. Now for the LCD. Now let's look at what we got here. We got x minus 2 in the denominator, and we also got a 3 in the denominator as well. So we're just going to have to combine those two together to get our LCD, which is in this case 3 times the quantity x minus 2. See, we got a 3 here, and we also got x minus 2. So we're just going to have to put those two terms together. And then we're going to multiply each and every term in this equation by this LCD, which is 3 times the quantity x minus 2. So 3 times the quantity x minus 2 will be multiplied by the x over x minus 2. And that's equal to 3 times the quantity x minus 2. That's going to be multiplied by the 2 over x minus 2. And then minus, let's see, I'll put the 2/3. I'll go and write down the 2/3. And then put the 3 times x minus 2 out here. And now we're going to simplify all of this. For this right here, that x minus 2, those divide out. So you're going to be left with 3 times x, which is 3x. And that's equal to, for this term right here, the x minus 2's divide out. All you'll be left with is 3 times the 2. That's going to give us 6. And then minus, now I'm going to simplify this right here. This 3 is like 3 over 1. The 3 in the numerator and the denominator divide out. You're going to be left with a 2 times the quantity x minus 2. And now let's simplify the right-hand side. Bring down the 3x. And that's equal to 6. Now that minus, change the sign of everything in the parentheses. So minus 2 times x will be minus 2x. And then minus 2 times a minus 2 would be a plus 4. And then add my constant term, 6 plus 4 will be 10. So I got 3x is equal to 10 minus 2x. And then the next step would be to get all the variable terms on one side. So I'm going to move the minus 2x over to where the 3x is by adding 2x on both sides. So 3x plus 2x is 5x. And that's equal to 10. And to solve for x, I'm multiplying by 5, so I need to divide both sides by 5. That means x is equal to 2. Now let's compare that to our restricted value. X equals 2 is our restricted value here. So that means we need to cross out that x is equal to 2. And that's going to mean that this rational equation has no solution. No solution. Or we can use a circle with a slash to indicate the empty set, because there's no value of x that will satisfy that equation. And by the way, if you were to do the check on this one, you'll see that you're going to get a 0 in the denominator. And of course, division by 0 is undefined. Okay. Now let's say you came across a problem like this one. Consider the equations y1 is equal to x, 1 over x plus 4 plus 1 over x minus 4, and y2 is equal to 22 divided by x squared minus 16. Find all the values of x for which y1 equals y2, and check. So here we're told y1 is equal to y2, and we want to find all the values of y. In this case here, y1 is this expression right here, 1 over x plus 4 plus 1 over x minus 4. Now that's going to be equal to y2, which is this expression right here, 22, divided by x squared minus 16. Now, before I do anything, I need to factor x squared minus 16 in that denominator. So let me bring that 1 over x plus 4 plus 1 over x minus 4 down, or rewrite that, and then that's 22. Now, x squared minus 16, that's a difference of two perfect squares. And if you're not familiar with the difference of squares here, a squared minus b squared. When you factor this out into two binomials here, and that's only for the differences of squares, a breaks up as a times a, and b breaks up as b times b. Now, one has to be plus, the other one has to be minus. So a squared minus b squared breaks up as a plus b times a minus b. That's just a rule for factoring the differences of perfect squares. I'm going to apply that to x squared minus 16. X squared breaks up as x, and x. 16. One number times itself gives me 16. Has to be 4 because 4 times 4 is 16. One has to be plus, the other one has to be minus. So x squared minus 16 factors as x plus 4 times x minus 4. And before I solve this, I need to find out what my restricted values are going to be. In this case, I got x plus 4 and an x minus 4. So I need to set x plus 4 equal to 0, and I also need to set x minus 4 equal to 0. So for x plus 4 is equal to 0, if I subtract 4, you'll get x is equal to negative 4. And then for the x minus 4 is equal to 0, you'll get x is equal to positive 4. So I have two restricted values. One will be x equal negative 4. The other one will be x equal positive 4. And now I need to find out what the LCD is going to be. Let's see. I'll write this over here. I only got x plus 4 and x minus 4. So the LCD will have to be x plus 4 times x minus 4. Has to be. Now I'm going to use that to multiply each and every term in this equation by that LCD. So here's what we have. X plus 4 times x minus 4 will be multiplied by that first term of 1 over x plus 4, and then plus x plus 4 times x minus 4 will also be multiplied by 1 over x minus 4. And that's equal to, I'm going to write the 22 over x plus 4 times x minus 4. That's going to be multiplied by x plus 4 times x minus 4. That's the LCD. Now I know that line is very lengthy, but when I simplify this, it's going to be quite easy because watch this. The x plus 4 divides out here. The only thing you'll be left is 1 times x minus 4, which is x minus 4, plus this part right here, the x minus 4 divides out. So now you got 1 times x plus 4, which is x plus 4. And then on the right side, both the x plus 4 and both the x minus 4 divides out. Only thing you'll be left here is 22. So I get x minus 4 plus x plus 4 equals 22. Now, combine like terms. Notice the minus 4 and the plus 4 are gone. You got x plus x, or 1x plus 1x, that's 2x, equals 22. Divide both sides by 2. X is equal to 11. Now, is x equal 11 one of our restricted values? And the answer there is no. So that's how you can do the check right there. So x equals 11 is the solution to that linear equation. Well, rational equation, I should say. Okay. Last thing we'll look at in this video is the types of equations. And there are 3 types. One is the identity, and that is where an equation that is true for all real numbers for which both sides are defined. So when you get an identity, that means your equation is going to be true for every real number. Conditional is where an equation is true for at least one real number. Those are the ones we've been doing throughout this whole video, because we came up with an equation with one solution. And also we did a couple of equations where it wasn't true for even one real number. That's called an inconsistent equations. Okay, so if you remember those examples that I did where I had no solution or the empty set, that's the inconsistent equation. That equation will not be true for even one real number. So let's look at this example here. Solve and determine whether the equation 4 times the quantity x minus 7 equals 4x minus 28 is an identity, a conditional equation, or an inconsistent equation. So here I'm going to write my equation out. And then if I use a distributive property on the left side, this will be 4 times x, which is 4x, minus 4 times 7, which is 28. And that's equal to 4x minus 28. Notice they're both the same terms, the same expression on both sides. So that means I have an identity equation. That's an identity, okay? Because 4x minus 28 does equal to 4x minus 28. Okay, and another example of this. Let's say I want to solve and determine whether the equation 4x minus 7 equals 4 times the quantity x minus 1 plus 3 is an identity, a conditional equation, or an inconsistent equation. Let's see, 4 No, 4x minus 7. Okay. So let me write it over here. 4x minus 7 equals 4 times the quantity x minus 1, close parentheses, plus 3. All right, in this case, the left side, we just bring that down. The right side, we'll need to remove the parentheses and combine like terms here. So if I do 4 times x, that will be 4x minus 4 times the 1, that will be 3. No, that'd be 4. X minus 4, and then bring down the plus 3. And then combine like terms. Negative 4 plus 3 will be negative 1. So I got 4x minus 7 is equal to 4x minus 4 plus 3 will be minus 1. Now, when I attempt to get all the x's on one side of this equation by subtracting 4x on both sides, notice that the 4x's on the left side are gone. Also, the 4x's on the right side are gone. I'll end up with a negative 7 on the left side equaling to negative 1. And does negative 7 equal to negative 1? That is a false statement because negative 7 does not equal to negative 1. So this is a type of equation that is considered to be inconsistent. Because you're not going to find a value of x that will satisfy that linear equation. So here you have an inconsistent equation. Okay. All right, so that will conclude this video on section 1.2, dealing with linear equations and rational expressions.